Hello and welcome to helpyourmath.com. In this video, we are going to look at question 8 of the Math 2 6.5 Final Exam Review. In question 8, we're asked to sketch a graph of a rational function. To help us, we're going to find the domain, any discontinuous points, vertical and horizontal asymptotes, and then we're going to sketch that graph. Okay, so starting with the domain, a domain consists of all the values of real numbers that we can plug into a function that will produce a real number value as an output. On a rational function, we have restrictions on the domain when the denominator is equal to 0. So to figure out our domain, we need to figure out what's going to create zeros in the denominator. So we're going to look at the denominator, x squared plus 3x minus 40, and we're going to see what gives us zeros in there. And so this is a quadratic. We want to factor the quadratic. We can use a shortcut because the leading coefficient is 1, and the winning combination are the two numbers that multiply to negative 40 and add up to 3. That would be positive 8 and negative 5. So we have x plus 8 times x minus 5 is equal to 0. Now we set each factor equal to 0. So if x plus 8 is equal to 0, we're going to get a 0 at x equals negative 8. And x minus 5 is equal to 0. We're going to have a 0 at positive 5. So if we were to plug in negative 8 for x or 5 for x, we're going to have a 0 in the denominator, which is not allowed. So those two values are pulled out of the domain. So the domain consists of all real numbers except for negative 8 and positive 5. To write that in interval notation, we're going to say, okay, we can plug in anything we want from negative infinity all the way to negative 8, but we can't include negative 8. Then we're going to start back at negative 8 and go all the way up to 5. Pull out 5 from the domain, and then it'd be 5 to positive infinity. So we can plug in any other value, just not negative 8 or positive 5. Okay, the domain is done. Next, we're going to see if this graph has a hole. A hole is a factor of the denominator that can cancel out with a factor of the numerator. If any of those exist, then at that x value, there is a hole. A hole is just an open circle. So let's look at our function. We're going to factor the numerator. It's a difference of squares. It's going to be root minus root times root plus root. And then over what we factored already, x plus 8 times x minus 5. Aha! It does look like we can simplify a factor of x minus 5, indicating to me there is a hole at x equals 5. Now, I said that a hole is an open circle, which means we need to figure out where exactly at x equals 5 this hole will be. How do we determine the y-coordinate of this? Well, we're going to use the simplified version of our rational expression, which is now x plus 5 over x plus 8. And to determine the value of the hole, we are going to plug in 5 into the simplified function. And now we can, because we got rid of that piece of the denominator. So to figure out the y value, we're going to plug in 5. We're going to have 5 plus 5 over 5 plus 8, which will give me 10 over 13. So this is the y-coordinate. The coordinates of the hole will be 5, 10/13. Okay, so that's done. Now, we may notice that we have this x plus 8 factor left in the denominator. What does that mean? That means that there is a vertical asymptote at negative 8. So we're going to have a vertical asymptote located at x is equal to negative 8. And what we're interested in now is figuring out points around that vertical asymptote to kind of see the behavior of the graph. But we're not totally there yet because we still have to figure out the horizontal asymptote. This graph does have a horizontal asymptote. And to calculate where this horizontal asymptote is located, we look at, because the exponent the degree of the numerator is equal to the degree of the denominator, we look at the leading coefficients. And the horizontal asymptote is going to be located at the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is 1. So we're going to have a horizontal asymptote at y equals 1. Now, the reason we did that again was because the degree of the numerator matched the degree of the denominator. If you need to review what happens when they don't match, that's a separate video that we're not going to look at here. You are welcome to look at that video, though. I will post it right below in the comments. Okay, so now let's set up what we have. We have x equals 5 is a whole. So we have 5, 1, 2, 3, 4, 5. 10/13 is like just less than 1. And we have a vertical asymptote at -8. I think that's all the way over here if I counted correctly. So we're kind of going to be off the graph here. Not my greatest choice of graph. And we have a horizontal asymptote at y = 1. So this is the basic layout for kind of the framework for f of x. What we want to do is we want to see what's going on around those asymptotes, specifically around the x asymptote. Now we do have that hole all the way over there that's going to help us, but we still want to see what's going on, where is this graph located around the vertical asymptote x = -8. Because what's going to happen is as we get closer and closer to -8, it's going to be going either way up to positive infinity on the y-axis or way down to negative infinity on the y-axis. We want to get a sense of which one it's actually going to be doing. So we're going to set up a table, and I know I'm kind of running out of space here, so I'm going to try to mash it in right here as best I can. And what we want to look at is points around -8. I do suggest using some fractions. So on the left of -8, let's look at -9 and -8.5. If you want to get even more, you can of course plug in more points as long as x is smaller than -8. And on the right, let's look at -7.5 and -7. And let's see what happens when we plug these values in. Again, I'm going to try to squeeze this in as best I can, but I do know I'm running out of space. For -9, now here's the beauty about the fact that we simplified our rational expression. We can use the simplified version. It will produce the same results as if we plug into the original function. So we're going to use our simplified version, which is great for us. I'm plugging in -9. I'm going to have -9 plus 5 divided by -9 plus 8. This will give me -4 over -1, which is +4. So I know 1 point on my rational expression, rational function is -9, 4. So that's going to be like right here, 1, 2, 3. So there's 1 point. Okay, what happens when we plug in -8.5? And I know you're thinking, oh no, not a fraction, but hey, it's a half. They're really nice. Let's talk about this together. We have -8.5 plus 5 over -8.5 plus 8. -8.5 plus 5 is -3.5. -8.5 plus 8 is -1/2, right? Because the -8 and +8 cancel. We're still left with that -1/2. All right, okay, so this is a little bit tricky. I'm sorry. Let's see, this is 6, 7, -7 over 2. We want to convert to division, so divided by -1/2. That's going to be -7 over 2 times the reciprocal, 2 over 1. We end up with, whoops, wait a minute, times negative. There we go. A negative times a negative is positive, and then we end up with +7. Okay, so as we're getting closer, so 8.5, -8.5 is like right here. This was 4, 5, 6, 7. We can see that it's getting, as we get closer to -8 on the left, it's getting bigger and bigger and bigger, right? The y values are getting bigger and bigger. So I'm going to change the color of this graph just so that it stands out since I kind of have everything crunched in here. But it's going to kind of be over here. It's going to go up towards that vertical asymptote. It will never cross the vertical asymptote. These graphs will not cross the vertical asymptote ever. They'll get really close. They're never going to cross it. Okay, so that's the left side. We're not done yet. That's only half of the graph. The other half is going to be to the right of -8. We already have one sort of point. We have that hole over there. Now, what's interesting about horizontal asymptotes is we can jump over them in the middle of the work. We're not going to in this example, but we could, and that's okay. The horizontal asymptote just says what the graph is doing at the end. So as x gets smaller and smaller and smaller, the values of f of x are going to get closer and closer and closer to +1. And the same thing's going to happen as x gets bigger and bigger and bigger. But let's see what's happening right around -8. We're going to plug in -7.5. F of -7.5. We have -7.5 plus 5 in the numerator over -7.5 plus 8 in the denominator. That's -2.5 over +1/2. And this will be -5 over 2 if I convert it, divided by +1/2. That's -5 over 2 times 2 over 1. The 2's will cancel. We end up with -5. So we have the point -7.5, -5. 7.5 will be like right here. 1, 2, 3, 4, 5. Right around there. And our last point will be -7. F of -7 We have negative 7 plus 5 divided by negative 7 plus 8. That is negative 2 over 1, which is negative 2. So negative 7, negative 2 will be here. And this is just a rough sketch of the graph. These do not have to be perfect. I never get these perfect. What I'm going to do is I'm going to try to meet that hole over there, because the graph will get really close to the hole and then it jumps over it and continues on, getting closer and closer and closer to positive 1. This has been question 8 on graphing rational functions. Thank you for stopping by.